In this video, we're actually going to get started with the actual big content for this course. And we're going to start by talking about what is SQL. SQL is the big acronym that's going to be returning over and over through the course of this lecture. But before we get to that, let's talk about databases in general. So, many years ago, databases was primarily really dry data. It was census, employee records, bank accounts, stuff like that. But in reality, as basically all of our lives become put into computers, and really when I say put into computers, it really means put into databases, basically everything that a computer stores, for the most part, is really in some type of database of one form or another. So everything you've read on a computer, everything you've seen on a computer, and maybe according to the NSA, everything you've ever done on a computer is recorded somewhere, everything on the web. Basically, all of science is in databases, all the medical data, so forth. It's very important that we have databases that work well because basically all of our lives are in databases now. So why are you taking a class on databases? Well, fundamentally because databases are interesting. Even beyond just knowing how to use them, understanding how they work will teach you a lot about how computer science works as well. For instance, databases is one of those few instances where there are very specialized programming languages. SQL is one example. And it's one of the few places where non-Turing-Complete languages is actually an advantage. We'll talk about why in a little bit. And because of these specialized programming languages are built just to really work with the sorts of things you want to do with databases, it means that you can write very succinct but powerful programs that can do a lot of optimization, that can do a lot of very fast and very expensive things easily. The other thing to talk about is, well, why don't you just store everything in flat files? Why do you have to go through the trouble of using all of these database software? And the big thing is that database software allows you to do things concurrently. What does that mean? It means that you can do many things at the same time. So often databases are used by many different people concurrently so that you can do something like YouTube is watched by hundreds of thousands of people at the same time. And if a database that YouTube stored all its videos on could only be accessed by one person at a time, it wouldn't be particularly useful. But in addition to just many people watching YouTube, many people are changing databases at the same time as well. And you want to be able to support both many people reading from your database as well as many people writing to your database. Okay, so let's go to the first multiple choice question of this video. What is the advantage to SQL not being Turing-Complete? Alright, so most programming languages are Turing-Complete, and what does that mean? Well, you can learn about that in some of your other theory computer science classes, so if you don't know what that is, you can kind of skip the rest of this multiple choice question. But the nice thing about SQL, which is the programming language primarily used for relational databases, is that it's a lot easier to optimize. You don't have to worry about a lot of the sorts of looping structures and things like that make it very hard to optimize standard programming language like Python or C++. Another thing is it tends to be much easier to write. It's a much smaller language that you have to wrap your head around. And in reality, number 3 there is also correct. Depending on which extensions to SQL you add in, SQL sometimes can actually be a Turing-Complete language, but that's once again beyond the scope of this class. Okay, so next we're going to talk about data models. So we've talked about how you represent data in a couple different formats already. For example, we've talked about the fact that CSV files are primarily relational models where you have records and you can represent that as tables of data like a spreadsheet. We've also talked about some more semi-structured models, specifically XML and JSON, which you can't quite represent as a table. Instead, you usually represent that as trees or graphs. So that's one thing that's really important to make sure that when you're talking about your data is how do you represent it? How does it connect to each other? The next thing to also talk about is what are you allowed to do with that data? So often you're able to do things like comparisons. Is this value bigger than this value? Equality, are they the same? You can do arithmetic and math on particular data objects. It's also important when you're building your database to think about what aren't you allowed to do? So what sort of constraints do you have? For instance, what types of data are allowed in different parts of your database? And so the model that we're primarily going to be talking about is that of relational databases. And here, basically, all the data that we're going to represent, at least for this first, 2/3 of the class are represented in the terms of tables. So here is an example table. The note to talk about the different parts of this table, the first thing we need to talk about are the attributes of this table. These are the column headers. These are the places where we're able to add data to. For instance, here we have 2 headers, that being the student's name as well as the student's favorite show. Okay, so those are the headers, those are the attributes for this table. Additionally, this database wouldn't be very useful unless we actually had data in there, which are normally called records or tuples or rows. They all mean basically the same thing for the purposes of this class. So we have a particular piece of information that says the student named Ian has their favorite show, Stargate, and so forth. Another important thing to note is that all relations have a particular name. They have a particular way for you to reach into this particular data. So we'll be using this particular form throughout the class in order to represent the data that's stored in these relations. Another thing we need to talk about are that of schemas. So we've talked about schemas already with respect to schemas for CSV, for JSON, for XML, but we'll also have schemas for relational database, schemas for SQL style databases. So what does that look like? Well, in general, a relational schema is the relation's name. In the previous example, it was shows, as well as an attribute list. What are all of the columns in that database? And optionally, you can also have the types of the attributes. So for example, it's a perfectly acceptable schema for the previous example to say we have shows and then in parentheses, name, comma, favorite show. This is the notation for how you represent a relational schema. Or if you want to add types, you would say shows, parentheses, name, text. So we have the type of the column after the name of that attribute. All right. So what is a database? A database is basically a collection of relations. So we had one relation, which is shows, but we could also have other tables all in the same database. So a database is a set of relations. And what is a database schema here? Basically, a database schema is the set of all of the relational schemas in the database. So each relation has a schema, and a database schema is the set of all of those. All right, so we've been talking a lot about relations. We've been talking a lot about tables. Why do we bother with storing data in relations? One, it's a nice and simple model. All right, tables are pretty easy to visualize. They're pretty easy to wrap your head around. And more importantly, is that often the data that we want to represent is actually stored in forms that we can convert to these sorts of tables. And so this is actually the abstract model that underlies all of these relational style database, all of the tables and so forth. And so it's very important that you understand how to represent your data and how to use your data that's in relational form. All right, so when we talk about schemas with respect to SQL, SQL is primarily a query language, meaning that primarily the way that you're using SQL is you're trying to select data from the database. However, SQL also includes other components that allow you to do things like to specify schemas, and we'll talk about that in the next video, for how to build relations from scratch before you start adding data to them. Last part of this lecture, multiple choice question. What is the difference between a record and a tuple and a row? Alright, so this was a little bit of a silly question, but for the purposes of this class, they're all basically the same thing. If you get into much more advanced classes on databases, they'll start to actually distinguish between what these different things actually mean, but for the purposes of this class, I'll use all three interchangeably.